Hi students, everyone. So here we are solving problems of application of derivatives. Yesterday we have solved the problems on slope of tangent, slope of normal, equation of tangent and equation of normal. So you can go through that, no problem. And now today also I am going to continue with the increasing and decreasing functions, and I think you also are waiting for the problems of increasing and decreasing, okay, so that we can go through the problems. So from morning I have not taken any single class. Really, for that purpose I was little bit dull from the morning, no problem. Now we can start our class, and I also feel that all of you are very much interested in this class because from morning you also have not done any work, okay. So how many of you are preparing according to the timetable, according to your time? So don't leave the preparation for your competitive exam as well as your board exam. Keep consistency and go on preparing. Don't leave or don't waste any time, okay. So do the revisions as much as possible. So the more revision, more perfectness. That's why I'm telling, please go through the problems more and more, okay. So now you just see we are going for our increasing and decreasing functions. We are going for increasing and decreasing functions. So that's why you must know wavy curve method. So what is wavy curve method? You just see here. First you have to solve the algebraic equation. For example, ax square plus bx plus c equal to 0. So if we say that this is your algebraic equation, so taking this algebraic equation you have to find the values of x by solving this algebraic equation. Let us consider alpha and beta. Alpha and beta are the two roots. Now what we have to do? We have got x is equal to alpha as well as x is equal to beta. Now we have to arrange this alpha and beta like this, okay, in the ascending order. You have to go in the ascending order, okay. You have to go in the ascending order and you have to arrange them. So say here you got alpha, say here you got beta, and you just see the highest power is 2. So that coefficient is a, which is positive. So for that we have to start our curve with positive side, go on the negative side, again we come on the positive side. So here it is positive, here it is negative, and here it is positive. So beta to infinity is one interval, alpha to beta is the second interval, and minus infinity to alpha is your third interval, okay. So this is called your wavy curve method, that you must know. So if you know this wavy curve method, it is very well and good, so that you can also understand some intervals, and you can also say where it is negative, where it is positive, and like that. So by using this you can find increasing and decreasing, because all of you know that if dy by dx is lesser than 0, it will be decreasing. If it is greater than or equal to 0, it will be increasing, okay. So that theoretical part you must know. So by looking at that, you can just see, if you say dy by dx is greater than or equal to 0, it will be strictly increasing. It will be strictly increasing, okay. So dy by dx is lesser than or equal to 0, it will be it will be strictly decreasing. Will be strictly decreasing. So you just go through this and remember that whenever the function is going to be decreasing, dy by dx is going to be lesser than or equal to 0. Whenever it is going to be increasing, it is going to be greater than or equal to 0. Okay. So with that, now we can go for our problems and we shall see how to solve increasing and decreasing functions. Okay. Let us begin this. So you just see the first problem. What it says: find the interval in which the function f given by f of x is equal to 2x square minus 3x is strictly increasing. So we have to check that where this function is strictly increasing. Clear? Okay. So for that we have to first consider f dash of x, that is nothing but your dy by dx. So you calculate f dash of x, so that will be 4x minus 3. Now equate this term to 0. Okay. And you can find the x value, no problem. Equating dy by dx equal to 0, what you are going to get? This implies 4x minus 3 equal to 0 and x equal to 3 by 4. So this is your root. Okay. So by finding this root, you draw this on the number line. This is 3 by 4 and you can just see the function is positive because highest power x is 2. So coefficient of x square is 2, therefore it is positive. The function is positive, no problem. We can draw the curve here like this. Okay. So you can just see here it is positive. Here you can see it is negative. So that is dy by dx is lesser than or equal to 0 if x belongs to open interval minus infinity to 3 by 4. Clear? Next, dy by dx is greater than or equal to 0 if x belongs to 3 by 4 to positive infinity. Okay. So therefore you can write it as strictly increasing in open interval 3 by 4 comma infinity and strictly decreasing in, you can just see 3 by 4 comma, so minus infinity comma 3 by 4, minus infinity comma 3 by 4. Okay. Minus infinity comma 3 by 4. Clear? This is the solution. Okay. So like this you have to solve your problem. So from this I think you have understood the logics, how to simplify, and also I think you have understood when it is increasing and when it is decreasing. So follow this method for all the problems so that you can see the increasing and decreasing terms. Okay. Okay, no problem. If you have any doubts you can ask, otherwise I will go for the second problem. If you have understood as our normal method, you can give the thumbs, no problem. So the second problem is given that f of x is equal to x square minus 4x plus 6. So here you have to see it is where it is strictly increasing and where it is strictly decreasing. Okay, no problem. So first let us find f dash of x. So you can just see it will be 2x minus 4. Now equate dy by dx is equal to 0, that is nothing but f dash of x equal to 0. So 2x minus 4 equal to 0 and 2x is equal to 4, x will be equal to 2. Clear? So from that you can check through this, that is negative infinity, positive infinity. Here you put 2 and you just see the curve goes like this and it turns here and it goes like this. So here it is negative, here it is positive. Okay, so from this dy by dx is lesser than or equal to 0 if x belongs to minus infinity comma 2, and dy by dx is greater than or equal to 0 if x belongs to 2 comma positive infinity. Okay, so here you can write f of x is increasing in 2 comma infinity, and f of x is decreasing in minus infinity comma 2. Okay, this is the solution for your second problem, and it is very easy that by taking 1 and 2 no problem. So here curve is not compulsory. Here wavy curve is not compulsory. Just I am telling that how to identify where it is positive and where it is negative. You can use this, but there is no conditions that you have to draw this curve. There is no condition that you have to use this method only. You can solve it any method. You can solve it with any method, and you can solve on your own method with another texts or another methods, but these intervals must be correct. Okay, we need these intervals, that's all. So here wavy curve method will be very simple, so that's why through that method I am explaining you. Clear? Okay, no problem. Now we can go for the third problem, that is find the interval in the given equation, that is f of x is equal to 2x cube minus 3x square minus 36x plus 7. So now you just differentiate this, you are going to get f dash of x equal to 6x square minus 6x minus 36. Equate this term to 0. That is equate dy by dx equal to 0. What you are going to get? 6x square minus 6x minus 36 equal to 0. Here you can see, you can take the term 6 common. If I take 6 term common, it will be x square minus x minus 6 equal to 0. Now you can simplify this algebraic equation, and you can see you are going to get x minus 3 into x plus 2. Clear? So x into x is x square, this is 2x, this is minus 3x, this is minus 6, no problem. You will get x minus 3 into x plus 2 equal to 0. Otherwise you can see x square minus 3x plus 2x minus 6. You can just simplify this. X is common, x minus 3, 2 is common, again x minus 3. You just simplify this, you will get this term. Now x equal to 3 and x equal to minus 2. You have two roots. So no problem, we can use our wavy curve method. Put it in ascending order. That means the smaller number, after this the greater number. Okay, smaller number, greater number, again more than this, like that. So now you can see this is positive. So see, the curve starts from positive side, it goes down at 3, again it comes up at 2. Okay, and again it goes like this. That means here it is positive, here it is negative, and here it is positive. That means minus infinity comma minus 2 union 3 to positive infinity. Here it is dy by dx greater than or equal to 0 in this interval, that x belongs to this term. And you can see that dy by dx is lesser than or equal to 0 if x belongs to minus 2 comma 3. Okay, so from this you can say that it is strictly increasing, it is strictly increasing increasing in minus infinity comma minus 2 union 3 comma infinity. Okay, and strictly decreasing in minus 2 comma 3, strictly decreasing in minus 2 comma 3. Okay, so this is your answer. Clear? So you can just see that it is increasing in minus infinity comma minus 2 union 3 comma infinity. Here it is increasing, and decreasing in minus 2 comma 3. Here it is decreasing. Clear? So very simple problems that you can understand, no problem. So go through it and you can understand them very carefully, no problem. Now I will go for the fourth one. See the fourth problem. F of x is equal to cos x. So here you can't use wavy curve method. Wavy curve method is only for algebraic functions. Please remember, wavy curve method is only for algebraic functions. But here you see that it is trigonometric function. Trigonometric functions also have curves. No problem. Trigonometric functions also have curves. So if you know the curves of trigonometric functions, you have to use according to trigonometric rules, not with the rules of wavy curve method. Please understand that. Okay, so you have to use through the trigonometric rules. Please remember that. So anyways, for the fifth one, you can't use wavy curve method. It is not algebraic function. It is log function and with rational function. So here you don't use wavy curve method. Here you can use your trigonometric functions, and trigonometric functions have an curves and all. So through that you can go, no problem. You can use the graphs. You can use the graphs of trigonometric function. Clear? Okay. So now let us go for f dash of x. So I will go for f dash of x, and you can just say differentiation of cos x is minus sin x. Okay. So now what are the intervals? Here intervals are given 0 comma pi. So x belongs to 0 comma pi. So see, if x belongs to 0 comma pi, here you can observe that here sin is positive in 0 comma pi, that is first and second quadrant. But what happens? Minus of sin x will be negative. In x belongs to 0 comma pi. So therefore you can say that f dash of x is lesser than or equal to 0 if x belongs to 0 comma pi. You can write like this. Hence it is decreasing. Hence it is strictly decreasing. Okay. On the same way, you can just see in pi to 2 pi. In pi to 2 pi, sin x is negative. But minus of sin x will be positive if x belongs to pi comma 2 pi. Therefore f dash of x is greater than or equal to 0. Hence it is strictly increasing. Increasing in pi comma 2 pi. In pi comma 2 pi. So strictly decreasing in 0 comma pi. You can write like this, no problem. But do you want a representation of the curve? If you want representation of the curve, I will solve through it. If you say yes, otherwise no problem, we can go for the fifth problem. So here I will check how many can you solve this. So I will give this as homework for you all. So try this problem. Definitely I know most of you cannot solve this. If you can solve, no problem, you solve it. If you can't solve, I will go through it in the next class, but I will give this as homework for all of you. So already it is present in your NCERT textbook, and you can go through the solution of NCERT textbook. There you can get the answers for this. No problem. Okay. So coming to the fourth one, do you need the graphical representation? If you say yes, no problem, I will solve. Otherwise, we can go for the next problem. Okay. So see here, what we have, minus of sin x. Okay. All of you know that the sine graph is like this. And this sine graph you can just see in the 11th class textbook, 11th class NCERT textbook. Already you may have seen in the 11th class NCERT textbook. It is given by very neat representation like this. This is sine curve, 0, pi by 2, here it is pi, here it is 3 pi by 2, and at this point it is 2 pi, and it goes on like this. Okay. So this is sin x. This is sin x. Okay. But we need minus of sin x. So minus of sin x will be the mirror image of this particular curve along with x-axis. The mirror image of this particular curve along with x-axis. That means it will change its nature like this. It will become like this. Okay. This is 0. Here this is pi by 2. Here this is pi. Here it will be 3 pi by 2. And here it is going to be 2 pi. Okay. So that you can see from 0 to pi it is negative. From 0 to pi you can see here it is negative. And from pi to 2 pi here you can see it is positive. So according to us, if it is negative, it will be decreasing. If it is positive, it will be increasing. Okay. So this is what the graphical representation. So that's why I say most of the times, please understand the graphs. Most of the times I say, whenever I go through sets, relations and functions chapter, I tell all the students, go through the graphs and understand the graphs, because those graphs can give you this answer very quickly. Because see, if you draw minus sin x directly with this graph, you can answer it in 1 second. You can answer it in 1 second. There is no need to solve all this. There is no need to solve all this. Quickly you can tell through the graph. Okay. That's why most of the time I tell, go through the graphs, learn graphs, understand the meaning of the graphs, practice those, because they are very, very important for competitive exams. But most of the students never do that, and they can't understand graphs. That's why. Okay. No problem. So now we can go for the 5-mark problems. So these are the 5-mark problems. Okay. So now we are entering into our part D section, and let us see one by one through these particular problems. Some of the problems I have solved in offline classes, some I am solving in online classes, and some of the problems may be missing from online class to offline classes, but don't miss any problem. You have to solve all the problems which I have solved in offline, and go through the online classes which are important. Okay. Because in most of the online classes I may miss some problems from your offline classes, and in offline classes I also may miss some problems which I have solved in online classes. But go through all the problems. They are very, very important. Okay. So now you just see this. Go through the first problem. Go through the first problem, that is a particle moves along a curve 6y equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as x coordinate. Y coordinate is changing 8 times as fast as x coordinate. That means first you write the given terms. What are the given terms? The given term is curve 6y equal to x cube plus 2. Okay. Next, one more term is given, change of y coordinate. That means dy by dt will be equal to 8 times of change in x coordinate. That will be 8 times of dx by dt. Here x is x coordinate, y is y coordinate. Okay. So y coordinate is changing 8 times x coordinate. So that's why I am writing dy by dt is equal to 8 times of dx by dt. 8 times of dx by dt. Clear? Okay. So I will simplify this, that it is going to be by differentiating 6 dy by dt equal to 3x square into dx by dt. Okay. So now you can see here we have dy by dt equal to 8 times of dx by dt. So that I will replace here dy by dt equal to 8 times of dx by dt. So that will be equal to 3x square into dx by dt. So you can cancel the terms, that dx by dt, and here 3 into 1, 3 into 2, so that 16 equal to x square. 16 equal to x square. Then x will be equal to plus or minus 4. Okay. X will be equal to plus or minus 4. So we shall solve for both the terms. If x is equal to 4, what will be y? 6 into y equal to 4 cube plus 2. So 4 cube is 64. 64 plus 2 is 66. Y will be equal to 66 by 6, that is 11. So 4 comma 11 is the first point. Go for the second point. What is the second point? You just go through it. If x is equal to minus 4, if x is equal to minus 4, you can just see 6y minus 4 cube plus 2. So 6y minus 64 plus 2. Y will be equal to minus 62 divided by 6. That is minus 31 divided by 3. Cancel this, so that you are going to get minus 31 divided by 3. That will be minus 4 comma minus 31 divided by 3. So these are your required answers. Clear? So this is also very simple problem. If you understand it, this is also very simple problem. No worries. Okay. So if you have understood, quickly give me as yes. And if you have any doubts, you can ask those things. On the same time, we can go for the next problem, the second one. Okay. The second problem, that is a car starts from a point P at a time t equal to 0 seconds, at a time t equal to 0 seconds, and stops at point Q. The distance x meters covered by it in t seconds is given by x is equal to t square into 2 minus t by 3. Find the time taken by it to reach Q. Also find the distance between P and Q. Also find the distance between P and Q. Okay, no problem. So let us go through it. There is a point P, there is a point Q. So car travels from a point P to point Q. So here you can just see the distance between this is given by x is equal to t square into 2 minus t by 3. This is the distance, and I know that dx by dt is velocity. Rate of change of distance is velocity. Clear? And this velocity is initially it is going to be 0 because the vehicle in rest position, and at the final point also it is going to be 0. Okay, because again it is in rest position. Clear? So this logics you have to use. Clear? Okay. Now you just see what is given. X is equal to t square into 2t minus 3. That is nothing but x is equal to 2t square minus t by 3. This is distance. And we can say that rate of change of displacement is velocity. We know that dx by dt is rate of change. Dx by dt is rate of change. That you can take it as velocity, no problem. And rate of change is 0 at t equal to 0, and it is 0 at the final point also. Okay. So first you calculate dx by dt. That will be 2t minus 1 by 3. 2t minus 1 by 3. So now we have to use dx by dt as 0, because after completing rate of change of this particular distance, at this point it is going to have again dx by dt as 0, because it is in rest position. Clear? So this is, this will be t cube. Okay, so that is 3t square. 3t square. Clear? So you can just see 3 and 3 will get cancelled. T square into t is t cube by 3. That is 3t square divided by 3. 3 will get cancelled. Here dx by dt is 0. 2t minus t square. So now by using this you can say here t is common, 2 minus t. T equal to 0 or t equal to 2. You have two choice, t equal to 0 or t equal to 2. Clear? Okay. So now from this you can just see, if t equal to 0, you are going to get what is x. At t equal to 0, that is initial position, x will be 0, no problem. At t equal to 2, you can just see x will be equal to 2 square 2 minus 2 by 3. Okay, so x will be equal to 4 into 3 into 2 is 6, 6 minus 2 is 4, 4 by 3, so that is 16 by 3. So you are going to have 16 by 3 units as your distance. 16 by 3 as your distance. Clear? Okay. So now I think from this you can understand it, no problem. So t equal to 0, t equal to 2 are the 2 points. So therefore from this you can understand your values, that is 16 by 3 units. 16 by 3 units. So if you have any doubts you can ask, no problem. This is 2t square. Clear? 2t square minus t cube by 3. So if I differentiate it, it will be okay. So here we have gone through little bit a small mistake. We can take it, no problem. That will be Here it will be 2t square, that means 4t, no problem. This is 4t and this is also 4t. So please correct it. That is going to be 4t. Small mistake has been done here. It is 4t. Okay. This is 4t. And here also this is going to be 4t. So here it is going to be 4. And t is going to be equal to 4. T is going to be equal to 4. Sorry for that. Okay, so now you can just change these terms, no problem. You put t equal to 4 and you can simplify it. So therefore, our solution will be x equal to 4 square 2 minus 4 by 3. So that is x equal to 4 square is 16 into 3 into 2 is 6, 6 minus 4 is 2, 16 into 2 is 32 by 3 units. Sorry for that. I have done some small mistake. So sorry for that. But you can take care of it. No problem. T equal to 0 and t equal to 4. Here t equal to 0 and t equal to 4. Okay. Sometimes it happens, no problem. But so quickly tell me, everyone, have you understood this? A small mistake has been occurred. No problem. Sometimes it happens with anyone. Today it happened to me. No problem. So here t is 0 and t is 4. You have got two choices. So for t equal to 0, x will be 0, no problem. And for t equal to 4, it will be x equal to 32 by 3. So quickly tell me, everyone, have you understood this? Have you understood this? Okay. So everyone understood this, no problem. Now we can go for the third question. Now we can go for the third question. Clear? So what is the third question? A circular disc. A circular disc. Say this. A circular disc of the radius 3 centimeters is being heated. A circular disc of 3 radius centimeters is being heated. Due to the expansion, its radius increases at the rate of 0.05 centimeters per second. Find the rate at which its area and circumference is increasing. Find the rate at which the area and circumference are increasing when radius is 3.2 centimeters. When radius is 3.2 centimeters. Okay, no problem. So see here, there is a circular disc. First you understand it. There is a circular disc with radius 3 centimeter. The radius is given as 3 centimeter. Clear? So we shall take the circle little bit more. Okay, so let us take, there is a circular disc with 3 centimeters. So let us take, this is the circular disc with 3 centimeters. Now what they are doing, they are going to heat this. They are going to heat this with the fire. Now this will increase. The radius will increase like this. Okay. So as the radius increases by heating the circle, as the radius is going to increase by heating this circular disc, now you have to calculate the rate of change of its area as well as circumference. Okay, so let us take, this is the circular disc with 3 centimeters. By heating this, it is going to increase its radius. It is going to increase its radius according to they are going to heat this, because this is a metal, everyone know. So when the metal is going to be heated, the metal is going to expand. So this metal is going to expand. So now we have to calculate rate of change of its area and circumference. Okay, rate of change of area as well as circumference. No problem. Let us solve this. So I think now you have understood the problem. There is a circle which is changing its radius, which is changing its radius. Okay, so now take area of circle is A. Area of circle is what? Pi r square. What is circumference of the circle? Circumference of the circle is 2 pi r. Now we have to calculate rate of change of area. So no problem, calculate dA by dt. That will be pi into 2r dr by dt. Clear? So r is equal to, given when the radius is 3.2 centimeters, they need the area and the rate of change of the radius is also given as dr by dt, which is equal to 0.05 centimeters per second. Okay, so use this, that will be dA by dt equal to pi 2 into 3 by 2 centimeters. Again dr by dt is 0.05 centimeters per second. No problem. So I will remove this centimeter and I will fill r value, that is 3.2, and I will also fill dr by dt, that is 0.05. So therefore quickly calculate this and tell me what will be the answer. Quickly calculate and tell me what will be the answer. Okay, so that you can see here the answer is going to be equal to 3.2 multiplied with 2 is 6.4. 6.4 multiplied with 0.05, it will be equal to pi multiplied with 0.32. So you can say this as 0.32 pi centimeter square per second. 0.32 pi centimeter square per second. Clear? So you can write like this, no problem. So you also check once calculations, because today I have done already one mistake. So there are the chances of getting mistake for me also. So quickly check this and you can verify it. Okay. On the same way, I will go for circumference. So if I calculate the circumference rate of change, that will be dc by dt equal to 2 pi dr by dt. dc by dt equal to 2 pi dr by dt. Okay. So now rate of change of circumference is going to be equal to 2 pi. So dr by dt is how much? 0.05. dr by dt is 0.05. Therefore dc by dt is equal to 0.05. So that means 0.05 multiplied with 2, that is 0.1. So 0.1 pi centimeters per second. 0.1 pi centimeters per second. Clear? This is your answer for the rate of change of area as well as rate of change of circumference. Clear, everyone? So this problem is new because I have not solved it in the previous thing, and in the previous classes also I have not done this. No problem. We have done one new problem. go through it and understand it. Okay, on the same way we can go for the fourth problem. Clear? Okay. So we shall see the fourth problem. See the fourth problem, that is the length x of a rectangle is decreasing at the rate of 5 centimeters and the width y. So that means length equal to x, and the length x of a rectangle is decreasing. That means rate of change of length equal to decreasing, means minus 5 centimeters per minute. Okay, minus 5 centimeters per minute. Next, and the width y, and the width y, and the width y is increasing at the rate of, and the width y is increasing at the rate of 4 centimeters per minute when x equal to 8 centimeter and y equal to 6 centimeter. Find the rate of change of perimeter and the area of rectangle. Find the rate of perimeter and the area of rectangle. Okay. So read the question very carefully and we can go through it. No problem. Width y, and here y is 6 centimeter. Area of rectangle is length into breadth, that is xy. Area of the length is xy. Perimeter of the rectangle is 2 times of x plus y. Okay. Because x is length, y is width. So area of rectangle is length into breadth, and the perimeter is 2 times of length plus breadth. Clear? So now you can calculate the rate of change of area as well as rate of change of perimeter. So rate of change of area is equal to x into dy by dt plus y into dx by dt. So all the terms are given. X is 8 centimeter, dy by dt is 4 centimeter, plus y is 4 centimeter, sorry, y is 6 centimeter. Y is 6 centimeter, y is 6 centimeter, and dx by dt is minus 5 centimeter. So 32 minus 30 is 2 centimeter square per minute. 2 centimeter square per minute. Clear? And perimeter dp by dt equal to 2 times of dx by dt plus dy by dt. That will be equal to 2 times of dx by dt is minus 5, dy by dt is 4. Okay, so therefore minus 5 plus 4 is minus 1, and this will be minus 2 centimeter square per minute. Minus 2 centimeter square per minute. Clear? So therefore rate of change of area is 2 centimeter square per minute. Rate of change of perimeter is minus 2 centimeter square per minute. These are the rate of change of area as well as rate of change of perimeter. Okay. So still we have 4 problems. And you can see here the 5th problem. You can see here the 5th problem is same as the 4th problem. The length x of the rectangle and is decreasing, width y is increasing. Same, it is same to the previous problem, that is 4th one. So you just solve it, no problem. And you can see the 6th problem and the 7th problem. 6th and 7th both are same. So here what happens, I will solve either 6 or 7. I will solve either 6 or 7. So on the same way you can solve the next problem. No worries. Clear? So now you can see that Now you can see that here perimeter is centimeter, no problem. Okay, so that means I am going to solve only some problems here, that is problem number 8 I will solve, and problem number 7 I will solve. So sixth problem is same as the 7th problem. So 6th problem you have to solve on your own, and 5th problem you have to solve on your own. Okay, so 5th and 6th you solve on your own. 7 and 8 I will simplify. 7 and 8 I will simplify. Clear? So 5 and 6 you have to solve. 7 and 8 I will simplify in the next class, because tomorrow I am going to finish this chapter. If I solve 7 and 8 in this class only, tomorrow I will not get more concept to explain, because tomorrow I have to cover maximum and minimum. So some problems on maxima and minima, that is local maximum and local minimum. So tomorrow I will cover this with these two problems. Okay, otherwise tomorrow it will be very short time. So I think 15 or 20 minutes this local maximum and local minimum will covered, and these two problems also take some 5 minutes, so that 5 or 10 minutes, that no problem. Here 15 minutes, here 10 minutes, we will get minimum 30 minutes. Okay, so tomorrow also in 30 minutes class we can take. Otherwise tomorrow it will be very small concept to explain. Okay, so because of time I will do it tomorrow. Okay, no problem. Let us continue this class tomorrow, and we shall finish our differential equations topic, application of differentiation topic tomorrow. Clear? Okay, so thank you everyone. I feel that all of you are preparing very nicely, and all of you are working the problems. I think all of you are working the problems. Clear? So don't stop your preparation. Keep on preparing till the exams get over. Clear? Okay, no problem. We shall meet in the next class, and we shall end this session here. Good night to everyone. Take care and bye.